This is going to be the odds of the review sheet. And so this first one, I'm going to graph the parent function 2 to the x first. So all exponential functions go through 0, 1, 1 comma the base, which is 2 in this case, and then the reciprocal of the base. So there is 2 to the x. I need to flip it over the x-axis upside down and shift it left 4. So 1, 2, 3, 4, it would get flipped over the x-axis. 1, 2, 3, 4, flipped over the x-axis. 1, 2, 3, 4, flipped over the x-axis. So it's going to look like that. And it would have a horizontal asymptote at y equals 0. Compare and contrast exponential growth and decay functions. So they will always have the same y-intercept at 0, 1, the same asymptote at y equals 0, the same domain of all real numbers, the same range of y is greater than 0, R for range. And they are basically just a reflection over the y-axis. So exponential growth is increasing versus decay is decreasing. So you could write a couple sentences with that information. Number 5, write the equation of an exponential function with base 4, so y equals 4 to the x, and it's been flipped over the y-axis. So that's in this direction, so the x is made negative. All right, solving simple exponential equations just means solving them without needing a log. So 4 to the 5th power, so 2 squared is 4 to the 5th power. So I haven't changed the value, just the base. So this is really 2 to the 10th. So now I can use the 1-to-1 property and x would have to be 10. So you might want to pause the video and try this one for yourself. So this is 2 squared. I'm cubing it. So we've got 2 to the 2x plus 1 equals 2 to the 6th, because I'm going to do 2 times 3 to get 6. So 2x plus 1 has to equal 6. I'm going to subtract the 1 to the other side. So 2x is 5. Divide by 2, and x would have to be 2.5 as my final answer. And then anything to the 0 power is 1. Great. You are going to try number 8 with fractional exponent rule. Let's see, I can graph an inverse function graphically or algebraically. So negative 3x plus 2 starts at 2 on the y-axis, goes down 3 over 1. So there's my original. So if I mark those as points, I'm at negative 1, 5, 0, 2, 1, negative 1, 2, negative 4. So I'm going to flip those points now. So my new points for my inverse are going to be 5, negative 1, 2, 0, negative 1, 1, negative 4, 2. So negative 4, 2, negative 1, 1, 2, 0, 5, negative 1. Oops, that should be a straight line. So if I want to find that equation, what I do is I switch x and y in the original function and get y by itself. So subtract 2 to the other side and divide by negative 3. So y equals negative 1/3 x plus 2/3. Let's see if that matches up to what we graphed. There's 2/3, and then, yep, the slope is down 1 over 3. Number 11, find the inverse algebraically. I'm going to switch x and y, and then I got to get y by itself. So I'm going to cube both sides to get rid of that cube root. So x cubed equals y minus 4. Add 4 to the other side. So y would equal x cubed plus 4. So 12, you're going to do evaluating logs. All right, 13. This would be a good one to pause and try these first. I could do this one in my head. 2 to the 5th is 32, so x would have to be 3 to make that 2 to the 5th. Let's see, on this one, I'm going to have to make the bases the same. So 2 squared to the 3x. So 2 to the x plus 1 equals 2 to the 6x power. X plus 1 now equals 6x. So 1 equals 5x if I subtract the x to the other side, and then I can divide both sides by 5. So my answer is going to be 1/5. On part C, you are going to set the inside of those logs equal to each other. X plus 1 has to equal 2x minus 5. Subtract x to this side, so we'll just have x, and then add 5 to this side. So x must be 6 to make this true. And then I get actually the log of 7 equals the log of 7. On part D, I need to divide by 6 on both sides. So I have the log base 3 of x plus 1 equals 2. 3 squared has to equal x plus 1, and I know that 3 squared is 9. So x would have to be 8 to make this true. Some good solving on number 14. 15, condense into one logarithm. So I'm going to be able to combine them using division, but first I need to move the power up inside the log. So I need to make this x to the 6th, and I need to make this y squared. So now I have the log base 3 of x to the 6th over y squared as my final answer. And this one, I can bring these together with multiplication, and then I've got division. So log of x squared over y all inside the log. Let's see, 16, you are expanding. All right, 17. So whenever there's a log, it's always going to go through 1 comma 0. If it's a base 2 log, it's going to go over 2 up 1, or over the base up 1, and then it's going to kind of follow down this way towards that vertical asymptote of x equals 0. All this does is shifts everything right 1. So right 1, and my asymptote goes right 1 to x equals 1. So there's my log graph that's been shifted right 1. If it's a base 4 graph, it still goes to 1, 0, but now it goes over 4 up 1 and bends towards that x equals 0 asymptote. This is going to get flipped upside down, so it's just going to go in this direction instead. Still, x equals 0 would be the asymptote. The natural log has a base of e. So we're going to go to 1 comma 0, but then at 2.7, we go up 1 because e is 2.7. And then x equals 0 is still the asymptote. And this is a base 3 graph. So 1 comma 0, 3 comma 1, bending towards the asymptote. And this shifts everything right 1. So right 1, asymptote at x equals 1. And the domain would be x has to be greater than 1, and the range would be all real numbers because I can go up and down forever. Finding inverses of functions. So you'll try that on 18. Let's see, 19, solving application problems. 10,000 invested, annual interest rate compounded continuously. So I'm using PE to the R times T. How long does it take to double his money? So you could do guess and check, but I'm going to solve this using a log. Divide by 10,000 on both sides. So I've got e to the 0.024t equals 2. So I can take this and change into log form. It would be the log base e of 2, so the natural log of 2, equals 0.024t. So I'm going to take the natural log of 2 and divide by the 0.024. So it will take 28.9 years is what I got. Let's see, bird is growing bacteria. There's 200 present at the beginning, and after 6 hours, there's 450. So let's calculate our K value. 200 turns into 450 e to the K times 6. So divide by 200 and then turn it into a log. So 450 divided by 200. So 2.25 equals e to the K times 6. So log base e of 2.25 equals K times 6. So I'm going to take the natural log of 2.25 and divide by 6. So K is 0.135. Then it says how many hours until there are 5,000 present. We're starting with 200. We know our K value, but this time we don't know our time. So I would divide by 200, take the natural log of what I get, divide by my K value, and you should get 23.8 hours. And the last one is Newton's law for the odds here. Boiling water for tea is 100 degrees Celsius. After 2 minutes, the tea is 78. So we're going to calculate K. So 78 equals room temperature plus 100 minus room temperature, E to the K times 2 minutes. So this is 79. We're going to take 78 and subtract 21. So we get 57 is 79E to the K times 2. So we're going to divide by 79, change it into log form, log base E of 57 over 79 equals K times 2. Take the natural log and divide by 2. So K is negative 0.163. Now she wants her T to be 42 degrees. So we're going to keep surrounding medium the same, but now we're starting at 78 degrees. So subtract your 21. 78 minus 21 is 57. So I'm going to take 21, divide by 57, take the natural log, and divide by my K value to get T. Sounds like she should wait another 6.1 minutes to drink her tea. Hope that helped.